Welcome to today's lesson. We are going to look at problems involving the lens formula and magnification formula. Before we go to tackling the problems, we need to look at these important points. We have that distance of real objects, real images, and focal length are positive values. Then when we have virtual images and virtual distances, we are going to use negative sign. Then the focal length of a diverging, that is concave, is negative. Now we look at the first question. We have that an object is placed 10 centimeter from the diverging lens or focal length 15 centimeter. Find the position of the image formed. State the nature and the image formed. We have the solution. First of all, you always need to write the values that are given. F is negative because we are considering a diverging. So we have negative 15 centimeter. We have U, which is 10 centimeter. So applying the lens formula, we have 1 over F is equals to 1 over U plus 1 over V. We substitute the values here. We get that 1 over V is equals to minus 2 minus 3 over 30, which is negative 5 over 30. You get that V is negative 6 centimeter. This implies that the image is virtual and it is 6 centimeter away from the lens. We move to the next question. We have an object is placed 20 centimeter in front of a convex lens of focal length 12. Find the position and the nature of the image formed. Again, we start by writing the values that are given. F is equals to 12 centimeter. U is equals to 20. So we write our lens formula and then we substitute the values. We have 1 over 12 is equals to 1 over 20 plus 1 over V. So by substituting and rearranging so that we can get 1 over V, you get that 1 over V is 2 over 60, which is 1 over 30, which implies that our V is positive 30 centimeter. So that means that a positive value means that real image is formed. Therefore, real image is formed 30 centimeter away from the lens. We move to the next lesson or the next question. A 4 times magnified virtual image is formed of an object placed 12 centimeter from a converging lens. Calculate the position of the image and the focal length of the lens. So we start by the values that are given. U is equals to 12 centimeter. It's clearly given here. M is 4 times, so magnification is 4. So we start by the formula of getting magnification. M is equals to V over U. So by substituting, we get that V is equals to 48 centimeter. But remember, we are told that the image is virtual. Therefore, that implies that V is negative. Now, to get F, we use the lens formula. We substitute values. Our U is 12. Our V is negative 48, so we have 1 over 12 minus 1 over 48. When you substitute and you get the subtraction, you get that a 1 over F will be 3 over 48, which is 1 over 16. Therefore, our F is equals to 16 centimeter. Remember, after getting 1 over F, to get F, you get the reciprocal of your value. Then we move to another question. We have an object is placed A 20 centimeter and B 5 centimeter from a converging lens of focal length 15 centimeter. Find the nature, position, and magnification of the image formed in each case. We start with the first one. U is 20, F is 15. So applying the lens formula and then substituting, we have that our 1 over V is equals to 1 over 15 minus 1 over 20, which gives us that 1 over V is equals to 1 over 60. Therefore, V is equals to 60 centimeter. To get magnification, we apply the formula for magnification. M is equals to V over U. We substitute the values. 60 over 20, you get 3. So our magnification is 3. Therefore, we can say that because this one is positive V, we can say that a real image is formed 60 centimeter from the lens on the side opposite to the object, and it has a magnification of 3. We move to the second part. We have that U is equals to 5 centimeter, F is equals to 15 centimeter. So that now when we substitute our formula, we have that 1 over 15 is equals to 1 over 5 plus 1 over V, where we have that 1 over V is equals to 1 over 15 minus 1 over 5. When you subtract, you get the LCM is 15. You get that it is negative 2 over 15, which implies that V is equals to negative 7.5. Negative means that a virtual image is formed 7.5 centimeter from the lens. The magnification, you just get V over U, you get 1.5. So our M is 1.5. So we have another question here. An object is placed 12 centimeter from a converging lens of focal length 18 centimeter. Find the position of the image. You have U, which is 12, F, which is 18 centimeter. You have your lens formula. We substitute. Again, you get that 1 over V will be 1 over 18 minus 1 over 12. Getting the LCM and then subtracting, you get that our 1 over V is negative 1 over 36, which implies that our V is negative 36 centimeter. Again, because V is negative, a virtual image is formed, which is 36 centimeter from the lens. Then we have another question. An object 5 centimeter high is placed 15 centimeter in front of a convex lens of focal length 10. Find the position and the size of the image, and of course you are supposed to get the magnification. We start by writing the values that are given. Our height of the object is given as 5, U is given as 15, and F is given as 10. So using the lens formula and then substituting, we have 1 over 10 is equals to 1 over 15. So that now you can be able to get 1 over V, which is, when you subtract, you are going to get that 1 over V is 1 over 30, therefore V is equals to 30 centimeter. So V is positive, so a real image is formed. Then the size of the image, HI, we apply the definition of magnification. We know that it is the height of the image over the height of the object, or image distance over the object distance. So from here we can be able to make the height of the image the subject of the formula. So we just need to multiply through by HO, where HO is the height of the object. And then we substitute the value. The height of the image is 30, not the height but the image distance, V is 30, we have calculated. The object distance is 15, and the object height is 5. So by multiplying and dividing by 15 by 15 1 by 15 2, you will get 2 times 5. You get that the height of the image is 10 centimeter. Now to get the magnification, we use the formula. M is equals to V over U. Our V is 30, our U is 15. So you are dividing and getting that our magnification is 2. From there we have the assignment. In the first question, you are supposed to draw the rays to show how the final image is formed. You have the first lens, we have the object, then from the object this will form an image, then that image will be the object of the second one. So you are supposed to draw using the ray diagrams and be able to get the final image. Still we have another question. Make sure that you calculate and get the values that are given. Thank you, and be ready for the end of topic exam, and practice and ensure that you revise thoroughly. Thank you, and may God bless you.